Hi, welcome to the channel Too Irrational. I'm Pranay Sharma, and in this video we are going to see the solutions of CS1B paper conducted by IFoA Institute in April 2023. We are going to go through the detailed solutions, but if you want the solution sheets, I leave a number down in the description where you should message, WhatsApp or Telegram your email ID and ask for CS1 answer sheets, and we will email you the same. If you find any mistake in my solution, do write down in the comment and I'll pin the comment so that others can see them too. Now let's get started. Question number 1. Simulate 10,000 values from a normal 0,1 distribution using an appropriate R command. You should save the generated values in R for later use. So question number 1, first part, I will store it as Z, or let's store it as N, normal distribution. So we will say R norm want 10,000 values. Now these are random values, so you can set a seed. Even if you don't, does not matter, but I'll do it anyways. I'll say set dot seed. I'll write it as 2023, and this would be standard normal distribution, random numbers. Second part, simulate 10,000 values from a chi-square 4 distribution using an appropriate R command. You should save the generated values in R for later use. So I'll write it as C4 R chi-square. We want 10,000 values from our degree of freedom to be 4. Discuss the main disadvantages of using the inverse transform method from simulated values from a chi-square distribution. Disadvantages: chi-square distribution range is 0 to infinity. It lacks the negative values. And the second would be chi-square is predominantly positively skewed, hence will have more weightage on the lower values. Fourth part, simulate 10,000 values from a T4 distribution using your answers to part 1 and part 2, explaining your answers. You should save the generated values in R for later use. So we know that T distribution with degree of freedom K would follow a standard normal distribution upon square root of chi-square distribution with degree of freedom K upon K. Using the same thing, we'll say T4 will be equal to, I have N from standard normal distribution and square root of C4 by 4. That becomes the simulated values. Then fifth part, simulate 10,000 values from a T20 distribution by modifying your R codes from part 1, 2 and 4 where necessary. You should save generated values in R for later use. So here we will have to change this. We can use the standard normal distribution from part 1. This is C20 R chi-square. We want 10,000 values and degree of freedom 20. Then we can use that to make T20. Last part, demonstrate an important property of T distribution by presenting and comparing two appropriate plots of values simulated in part 4 and 5. So we have T distribution with two different degrees of freedom. One is 4 and then is 20. So we want the property that is related to the increase or decrease in the degrees of freedom. So first we can make the histogram for T4 and histogram for T20. So these are the two graphs. You can see that the range for T4 was going from -10 to +10, whereas here for T20 we are going only from -4 to +4. So clearly, as the degree of freedom is increasing, the variance is decreasing. Then you can talk about the symmetricity. In both cases, they are perfectly symmetric around 0. So we can say variance of t distribution with parameter 4 is more than the t distribution with parameter 20. From the graph, we can observe that t distribution is symmetric about 0 and variance of t is inversely proportional to the parameter. Let's go to the next question. Question number 2. Consider a sample of 1000 insurance policies. For each policy, there is a record of whether the policyholder has submitted at least one claim during the last 6-year period, the age of the policyholder, and the duration of the policy. The number of policies X with one or more submitted claims is modeled as a random variable with a binomial distribution. X follows binomial 1000, p. State the underlying assumptions that lead to the choice of a binomial distribution for X. So they've already defined X. We just have to talk about what assumptions are we taking about P and other policyholders. The probability of submitting one or more claims P is independent and identical for all the 1000 policies. Each policyholder submits claim independent of other policyholders. Then use the command load this to load the observed data into R. This will create the data frame called CS1 policies with 3 entries in your R workspace. You can check the names of the entries with names CS1 policies. So these are the 3 things. We have age of the policyholder in years, duration of the policy in months, and claimed takes the value 0, no claim in 6 months period, or 1, at least one claim in 6 months period. The actuary wishes to fit different generalized linear model to the data, assuming that the number of policies with one or more submitted claims has the binomial distribution, and the link function of the GLM is the logit function. That's the canonical link function. Fit a GLM to the data such that T depends on the age of the policyholder and report the estimated parameter values. So let's load the data first. I'll right click, say open with RStudio, and yes, and here we get the data. These are the age, duration, and claimed are the variables. So we want to make our model. We'll say model 1 would be GLM with our claimed is the variable or the response variable. So claimed follows, and we just want age in the first model. We'll take the data as CS1 policies, and we want the family binomial. So that's our model 1. We want to talk about the coefficients, so just take model 1 dollar coefficients. These are the answers that we want. Third part, fit a GLM to data such that P depends on the duration of the policyholder and report the estimated parameter values. So now we want just the duration, so you can copy paste, and I'll say it is model 2, and here instead of age we want duration. Object duration, not for my spelling mistake. Okay, duration, now it should work. And here we have the coefficients. Fourth part, compare the fit of the model in part 3 and part 2 and 3 using the deviance and the Achaic's information criteria AIC. The first thing is we'll look at the deviation, because we'll say that both of these model have the same number of parameters. So I'll just take model 1 and their deviance and SD2 model 2 deviance, and I'll take the difference of the SD1 minus SD2. So difference is of 102, whereas the change in parameters or change in degrees of freedom is 0. We can also take the AIC number, same model 1, AIC, so clearly model 2 has a lower AIC and the smaller scale deviance for the same degree of freedom. Let's just show the degree of freedom as well, otherwise it might be confusing. If we just write that, I'll say df1 df residual, same thing I'll do here for df2 and I'll show the change in degree of freedom, that is 0. So we'll say change in scale deviance is greater than twice of change in degree of freedom, and model 1 AIC is greater than model 2 AIC. Both this method suggests that model 2 is better than model 1. Fifth part, fit a GLM to the data such that P depends on both the age of the policyholder and the duration of the policy, and report the estimated parameter values. Last is comment on which of these three models in part 2, 3 and 5 is the most appropriate. Justify your answer. So now for part 5, just copy this model, make model 3. I want age and duration, so age plus duration, that becomes our model 3, and we want the coefficients, so model 3 coefficients, here we go. For the last part, we need to give reason which model is better. We have already said that model 2 is better than model 1, so we'll just test model 2 and model 3. You can use AIC number, you can use other methods, change in scale deviance and everything else. I prefer doing ANOVA test. I'll take ANOVA model 2 comma model 3, and I will say this is test is equals to chi-square, right? So one thing you should always check is that your deviance, this deviance should be positive. It is positive, so I'm fine with this test. I will write it as test, and I just want the p-value of this test. So I'll say test dollar p-value. Clearly it is very less. So at 1% level, we have sufficient evidence to reject H0. Model 3 is better than model 2, or you can just say model 3 is best. Let's go to the next question. Question number 3. The file heights.rdata contains an rdata frame heights that consists of a random sample of heights of mothers, mother.height, and fathers, father.height, and their daughters, daughter.height in inches. Draw a scatter plot for each pair of the data. So first we'll load this data. One thing you should always do is make sure you have removed everything from the global environment, and then right click, open with RStudio. Yes. So here we have the data. Now you can individually make all three plots, or you can just plot heights, and we get a directly pairwise data for each one of them. So from the data we can see mother and father, it seems very random, or you can say very weak positive relationship. Father daughter, same thing, very weak positive relationship, but mother and daughter seems to have very strong positive linear relationship. Second part, comment on the relationship between the pairs of the data by referring to the plot in from part 1. So from the plot, height of mother and daughter has a strong positive relationship, whereas the height of father has a weak positive relationship with both height of mother and height of daughter independently. Third part, fit a multilinear regression model with the daughter's height as the response variable and mother's and father's height as explanatory variable. Your answer should show a summary of the output and the fitted equation. So I'll just say model 1 is equal to, we want linear model, so LM, we have daughter.height follows mother.height plus father.height, and I'll say data heights. We want to show the summary. This whole summary you should copy from here and paste it in your Word file. I'll not be pasting it anywhere here. But they also said that we need to show the equation, the fitted equation. So for the fitted equation, we'll say y hat is equals to, here estimate value alpha hat plus beta 1, from here x1 and beta 2 x2, and we'll specify what is y hat, x1 and x2. Fourth part, assess the effect of each explanatory variable on the dependent variable by referring to the R output from part 3. From the summary, p-value for coefficients of height of mother is 4 into 10 raised to minus 5. You can check that here. And for the height of father is 0.213. That is here. This tells us height of daughter is dependent on height of mother, but height of father is not significant. Part 5, plot the residuals of the model fitted in part 3 using a graph that is appropriate for checking if the estimated errors are independent of the explanatory variables. Here what we can do is we can take the residual values, $1 residuals, and we can plot it with father's height and mother's height. Let's take father's height as x. So this seems very random. There is no visible path, whether it is positively skewed, positively related or negatively related. It seems very random. Same thing I want for mother's height as well. So again here it seems very random. There is no visible relationship. We'll say from the plots we can say that the estimated errors are independent of the explanatory variables. Comment on the fit of the model by referring to the plot from part 5. So here we are not actually checking the fit of the model, how well the model is fitting the data, but whether the assumptions, especially the independent assumption of the model, is correct or not. So we'll say as in both plots, the errors are randomly scattered, the independent assumption of the models is valid and the model is a good fit. For the last part, a suggestion is made that when the mother's height is 61 inches and the father's height is 63 inches, the daughter's height should be 67.5 inches. Comment on whether this claim is likely by using an appropriate 95% predictive interval of the daughter's height based on the fixed model. So we will be creating a predictive interval. First I'll make the new data, write it as n data, data dot frame, want mother's height is equals to, I think 61 and 63, 61, 63. Father's height 63, and I'll use now predict function. We will give the new data as n data and we want interval as predict. So here we are, this is the confidence interval. So clearly this 67.5 is out of our interval. So we'll say as 67.5 is outside the 95% confidence interval. The claim is not using this confidence interval. Let's go to the last question. So question number 4, the table below shows the total claim amount 1000 per year Xij over a 5-year period for 5 insurance companies critical illness book of businesses. The data can be entered into R in matrix form using the following code. So here we have copy and paste here. This is the data. Next is calculate the empirical base credibility theory model 1, the following. So we have to calculate expected value of m theta, variance of m theta and expected value of s square theta. So we'll calculate number of rows, number of columns, we'll calculate the row means and mean of row means gives us expected value of m theta. We'll calculate row variance, we'll calculate the mean of row variance, that is our s square theta, that was part C, and using simple formula we can calculate the variance of m theta as well. In second part, calculate the expected claim amount for the company E using your answer from part 1. So company E is the 5th company. So first we'll calculate Z. And using this Z, we will calculate the expected value. So I'll have Z into X bar. We want X bar for the 5th value. So row mean, row dot means, and I want the 5th value for that. Plus 1 minus Z. I want M, that is our overall mean. So this is the predicted value. Next, the table below shows additional information that has been provided showing the number of claims Pij over a 5-year period for the 5 insurance companies. So this is the volume. And we have to calculate EBCT model 2 and the same things. So now for intermediate calculation, we'll have to calculate X, PI, P star, P, all of these values. Then we have M, that is our expected value of M theta. Then few more intermediate calculation. S, that is our expected value of S square theta. I have written it in C. And V, that would be variance of M theta. Fourth part, calculate the expected claim amount for company C using your answers from part 3, assuming that the number of claims for company C in the following year remains at 130. So first we'll have to calculate the Z values. They are different for each one of them. So I'm calculating ZI. Next we'll calculate the credibility premium. Again for each one of them. So I'm just calculating. We need only for fifth one, but it's fine if we calculate for each one of them. So I had written it as xi bar. Here I have just written x bar. It should be xi bar. And then we'll use this to find the final value. So 130 into, we'll have the fifth value of this credibility premium. So we have 655.61. If we just compare, here even in model 2, this 130 is much smaller than other values that we have for other companies. And when it comes to model 1, we will be assuming that for each year and for each company, the volume remains same. So we'll say there is a big difference in model 1 and model 2 answers, as model 1 assumes equal number of claims each year for each policies, whereas model 2, I will write here P5 comma I, not only just 6, because all of these values I comma 5 comma J, okay, because for all of these values is small compared to the number of claims of other companies in all years, hence results in smaller expected claim, or you can say smaller ratio of the total claim amount. So that ends our paper here. Overall, the paper was straightforward. It was easy. I was able to complete the paper in just above 1 hour. I'm sure you will be able to complete it in 1 hour 50 minutes. A few of the comments might be a little bit confusing, but otherwise the paper was very straightforward. So I'm expecting a high passing mark this time. So maybe 56, maybe 58, because even paper A was comparatively easier. But I'm hoping you don't have to worry about it. If you find any mistake, do write in the comment, and I would pin a comment with all the mistakes, so definitely check them out. If you like this video, like it, share it and subscribe. I'll see you in the next one.